Assalamualaikum. In this video, I will discuss to you the rigid bodies moving under the plane general motion or general motions. So first of all, bigyan muna natin ng meaning kung ano ang general motion or general plane motion. Any plane motion which does not fall in the category of rotation about fixed axis or translation can be put under the category of a general plane motion of. A general plane motion is a combination of translation motion and rotation motion. General plane motion is a sum of translation and rotation motion. To find the angular velocity of a body performing general plane motion, we use relative velocity method, which is one of the method for analyzing a general plane motion. To find a angular velocity of a body performing a general plane motion, we use relative velocity method, which is one of the method for analyzing a general plane motion. So, ang figure is nasa right. This is the steps on how to find A omega AB na given na ang ito yung figure A pin A and pin B. Step 1, locate a point whose magnitude and direction is known. The magnitude of point B is known. So sa figure, known daw ang point B. Step 2, locate a point whose direction has known, that is point A. Step 3, divide the motion of the body as a sum of translation and rotation motion. Translate the body with translating velocity, that is VB, and rotate it about a fixed point B. So here is the figure ng step 3. Step 4, write the relation of the relative linear velocity for a translating point. For point A, we will write a relation as shown. This is the relation as shown. Step 5, write the relation for the absolute velocity of the translation point. Simultaneously, draw the vector diagram of the same. So here is the vector diagram. There you are. For the relation, VAB can be found out, and then we substitute the value of VAB in the relation for relative linear velocity. We get an angular velocity omega. So this is the angular velocity omega. So here is the example. The figure shown 3 bars AB, BC, and DC, internally pin connected at B and C. So this is the general plane motion. And externally hinge supported at A and D. In the position shown, bar AB has a constant angular velocity of 6 rods. This is 6 rods. Okay. Anti-clockwise, find the angular velocity of the bar BC and CD for the instance shown. So this is the solution. Consider AB, yung sa AB kanina. Rod AB rotate about a point A. So, direction of velocity at point B would be perpendicular to the radial distance AB. Therefore, using relation between linear velocity and angular velocity on substitution the value, we get velocity of VB as 1.5 meter per second. 1.5 meter per seconds. Consider rod CD. Rod CD. Rod CD rotate about point D. So the direction of the velocity at point C would be perpendicular to the radial distance CD. Let beta be the angle made by VC with the vertical. From the geometry, the value of this 46.97 degree. Therefore, using the relation between linear velocity and angular velocity on substituting the value, we will get equation number 1. There you go. General motion of rod BC. For general motion, we will use relative velocity motion. First step, gayahin lang natin yung mga steps kanina na nasabi ko. Locate the point whose magnitude and direction is known. In the figure, the velocity of point B is known. This is point B. Step 2. Locate a point whose direction is known. That is point C. This is the figure. Always nasa right side ang figure. Step 3. Divide the motion of the body as sum of translation and rotation motion. Translate the body with translating velocity, that is VV, and rotate it about a fixed position B. So this is the figure. Step 4. Write the relation for the absolute velocity of the translation point. Simultaneously, draw the vector diagram of the same. On solving the triangle, we will get the velocity at point C at 2.2 meter per second. The relative velocity of point C is with the respect to B is 1.61 meter per second. Yan. S po yan. S. So, this is the process po. Yan. Ito yung diagram sa right. Then sa left naman, ang process ng pag-solve. Step 5. Write the relation for the relative linear velocity of translating point. On substituting the value, we get angular velocity of rod CB. Rod CB is equal to 4.025 rods per second. Now, kung naalala nyo kanina yung equation number 1, substitute the value of VC in equation 1 and we get angular velocity of rod CD is equal to 10.73 rod per second. So that's all for today's video. By the way, my name is Mohazir A. Senda, BSCE 2A. Thank you.